Hi learners, welcome. In this video, I'm going to give you introduction about symmetry and group theory. And so coming to the total topic, in the whole topic, we are going to read about introduction, what is the, why we have to read the group theory, followed by what are symmetry elements and symmetry operations. And these are the 5 symmetry elements and their corresponding symmetry operations we are going to discuss. Proper axis of symmetry, plane of symmetry, improper axis of symmetry, inverse, identity. This is total syllabus that we are going to discuss under the title of symmetry and group theory. I'll make small videos because it's a big topic. And after the symmetry elements and symmetry operations, we are going to discuss about the groups and subgroups, the relation between our finite group and its subgroups, congruency theorem, relations and classes. And then finally, we need to assign point group for each molecule, different types of molecules. Then we have to know what about Schoenfeld symbols and their notations. Then followed by representation of group by matrix, character of representation, great orthogonality theorem and its importance, character tables and their uses, and finally applications of group theory. So all these topics we are going to discuss one by one. I will make small videos. Please do watch, subscribe to my channel to learn all these topics. Now let's start today's video. We are going to discuss about introduction. And group theory is a mathematical way of study about molecular symmetry. So group theory is basically it's a mathematical subject, but that theory we are going to use to know symmetry of the molecules. Symmetry of a molecule gives information about its properties. So many properties we can understand with the help of this group theory. So those properties like we can know the spectrum, we can understand the spectras like infrared, Raman. Similarly, polarity of the molecule, chirality, and so many other properties we can learn with the help of group theory. Group theory can be considered as a study of symmetry. So basically here the study of symmetry of what we are going to read, we are going to read symmetry of compounds, different types of molecules. So collection of symmetry elements forms a group. If you take a molecule, it may have different symmetry elements. So then it comes under a particular group. Okay, so that we have to discuss. It allows you to determine that which vibrational transitions are allowed or forbidden on the basis of group theory, like IR spectra and electromagnetic resonance interactions to show different phenomena like polarization, dispersion, refraction, etc. can be explained with the help of group theory. And group theory is applicable in Raman spectroscopy as well. So these are the various applications and why we need to study group theory in chemistry. Okay, coming to the introduction part. Next, symmetry elements and symmetry operation. Let's see. In this video, we are going to read about symmetry elements and symmetry operations. In the next video, we'll discuss about symmetry elements one by one. First, in the next video, I'm going to explain proper axis of symmetry. Now let's see what is symmetry. The term symmetry implies that all the parts of a structure are in harmony with each other. Not only structure, symmetry means it's a common word we can implement to anything in the universe. You take a flower, if it has symmetry, then only it looks beautiful. You take a leaf, you take a human body, you take anything that you are using, so we'll be having symmetry. One or more forms of symmetry. So, what is the definition? They should be in harmony with each other as well as to the whole structure. That means the structure should be proportional as well as well balanced. So that's all about symmetry. For example, if I write like this, see, it looks good. So it has symmetry. But here you see it doesn't have symmetry. So symmetry gives a beauty to the nature. Okay, coming to the chemistry, because of symmetry, and if you know the symmetry of different elements, that will be helpful to study many properties of molecules. Now, so a molecule or an object. Okay, so what are symmetry elements and symmetry operation that we are discussing now? A molecule or an object is said to possess a particular operation, symmetry operation, if that operation, when you apply, it should leave the molecule unchanged. Example, if I say there is a molecule AB. When I applied symmetry operation, it should give again AB only. ABA. Then it has to give ABA only. It should not change the format. Okay, it should leave as it is. Then only it is said to be the operation, whatever you are carrying, said to be symmetry operation. And only we call it as symmetry operation. The element is said to be symmetry element. Okay, in order to do this, if you do rotation is a symmetry operation, then the element will be rotational axis of symmetry. Rotational axis of symmetry. For example, if I take a leaf, you can see here leaf can be divided exactly into half. That means it has a symmetry. So you can take rotation or reflection. If you convert through this line, then you will get the same leaf. So that is said to be symmetry. That means leaf is having a symmetry element. Like that, any element in the universe, if you see, mostly they possess symmetry in them. Now, each operation is performed with respect to a point, a line, or a plane. That's very important. This point, line, or plane are said to be symmetry elements. So, generally, symmetry elements are either whatever the operation might be, it may be a point or a line or a plane. Okay, so you only find these two. These two are the elements that you will be carried in all the 5 types of symmetry elements. Okay, so the operation that is carried through a point or a line or a plane is said to be symmetry operation. And this point, line or plane which we are using to carry that operation is said to be symmetry element. There are 5 symmetry elements. Let's see what are those. So symmetry elements. And corresponding symmetry operations. Symmetry operations. So the first symmetry element is proper axis of symmetry. Proper axis of symmetry. So it is indicated with the symbol C suffix N. We will discuss in detail about this. And here the operation is rotation. And what is the symmetry element here? You see, axis means line. Here we are going to use line as a symmetry element. What is the name of symmetry element? Proper axis of symmetry. Next is plane of symmetry. Second symmetry element is plane of symmetry. So plane of symmetry is having a symmetry element plane. That means this. Okay, it is indicated with sigma. Okay, and here the symmetry operation that we carry is reflection. Reflection. And next symmetry element is improper axis of symmetry. Improper axis of symmetry. It is indicated with the symbol as suffix N. And here the combined operation we used to do rotation followed by reflection. Always rotation should be followed by reflection. Next, fourth element is inversion. It is indicated with I, and here the symmetry element, symmetry operation is inversion through a center. Inversion through a center. So generally that center is center of gravity. Through center of gravity. So what is here? What is the symmetry operation that we are symmetry element here? Is a point. In this case, it's point. In this case, line followed by plane. Whereas here it is only plane, and here it is line. And the last one is identity. All elements in the universe, even including molecules, have one minimum symmetry element, that is identity. So this is said to be doing nothing operation, doing nothing, or you can say rotation by 360 degrees. 360 degrees rotation. It will give you RHS. So these are the 5 symmetry elements. So what is the difference between a symmetry element and the symmetry operation? When you carry an operation on a molecule, it has to leave either identical or equivalent molecule. Then only that operation is said to be symmetry operation, and that element is said to be symmetry element. So let me explain with one example here. For example, if I take water, here I'm going to take first one, proper axis of symmetry. So if I rotate it through this axis, let's say give numbering, even though we can't differentiate hydrogen atoms, to know that whether it is giving equivalent or identical structure, I'm going to write here. So when you rotate it around this axis, so 180 degrees rotation, this is 180 degrees rotation. Then this hydrogen comes to this place, this hydrogen comes to this place. So normally we can't differentiate with hydrogen atom, this is, with hydrogen atom, this is. That's why, so this is said to be equivalent structure. Is it identical with the original one? No. Still you have to carry another 180 degrees rotation to get same atoms to occupy their original place. So this is another time you have to do. This is said to be identical. So these two things you have to know. So what is equivalent structure? What is identical structure? Equivalent means we can't practically differentiate the molecule and the atoms, but you can see the places have been changed here. But if when you do second time, you are working the same places as usual, then it is said to be identical. So then we can call this element as symmetrical element and this operation as symmetry operation. Thank you for watching. In the next video, I will continue with symmetry. First symmetry element, that is proper axis of symmetry. Please subscribe, like and share to your friends. Keep watching my videos. Bye students. Bye.